Hi, good morning, good afternoon, good evening, going from west to east as you watch this keynote of the IGLC 28 conference, July 2020, in the shadow of coronavirus as we are online. My name is Rafael. I'm a professor at the Virtual Construction Lab at the Technion, Israel Institute of Technology. I'm also a visiting professor this year at the Centre for Digital Built Britain and the Division of Civil Engineering at the University of Cambridge. And it's really an honor for me to bring you a keynote on the topic of digital twins for construction. BIM and lean construction are both radical changes in the construction industry. I think most of us are very familiar with these two themes. Certainly, we have written about them in the past, many of us, and they feature in much of our research. But there are two other interesting developments in the construction industry, a very big growth in monitoring technologies and in the AI that supports them and their application to collecting data from construction sites. And we also are witness in other industries to the appearance of digital twins, a new way of not only monitoring, but also controlling and managing assets in the built environment. So what is a digital twin for those of us for whom the term is new? A digital twin is a computer-based replica of a real physical asset. That could be a building, it could be a train carriage, as it is in this case. And there are some key features of how this digital twin construct works. The physical twin is monitored by various sensors, cameras, etc., and they provide a stream of data to the digital twin. That information is interpreted, merged, converted into information that can be used to gain insights about the real physical asset. And on the basis of those insights, we can create simulations or analyses into the future to make decisions, smart decisions about how we will manage that asset. And in many cases, through telemetry and other means, we can actually implement those decisions in the physical twin in the real world by controlling it from the digital one. And then, of course, there are outcomes. And we can, over time, we can compare those actual outcomes to the predictions of our analysis and simulation tools to learn about how the system works. And that means, over time, that using machine learning, we can also improve our analyses and make better and better decisions. So it's a fairly natural step, as you can imagine, to apply digital twin ideas to the fixed infrastructure, to bridges like we see over here. But what I want to talk with you today is about the idea of applying digital twins to construction sites during the construction itself, before the assets are delivered and operational. And of course, we have both with assets and with construction sites, the physical and the virtual aspect. So how do we go about monitoring the construction sites? Well, we have an array of technologies that range from sensors through laser scanning, 360-degree images, and others. Just a few examples I'm showing here. Sensors placed in concrete to monitor their temperature as the concrete cures. 360-degree cameras, which are used to collect images of construction site every day, mounted on the helmet of a construction worker, and those are then interpreted using computer vision and can be compared to BIM models. Laser scanning of industrial facilities or of construction sites, which requires a great deal of AI to determine what we're sensing in those images. Or even, as you see here at the bottom, handheld reporting through mobile devices by construction workers. Think not only about the fact that we have a physical and a virtual dichotomy in the information, but we also have a dichotomy between information that represents status and information that represents intent in a construction project. So, for example, if we think about these before and after types of information, and we split them into physical and virtual on this two axes, then we can begin with what we call the project intent information, which is generally compiled in a BIM model and perhaps in construction plans. we undertake the activity of designing and planning to compile that information, and then we use that information to build, essentially to control the production of building on site in the physical world. The intent drives the physical reality. So we measure here, or we have the status of the physical world. We then monitor the status of the physical world to create virtual project status information. And of course, we can then compare the project intent to the project status to determine our progress and to the degree that we are satisfying the requirements. And in another step, we're also able to operate from the status or from the intent into the site itself. You can also imagine that if we were to create a physical model of a building from cardboard or something similar, that would fit here in the quadrant of intent in the physical world, where we represent what we intend to do, but we have a physical manifestation of that information. Now, the information can be of three types. It's physical or factual information as reality, which is actually what we have in the construction site. It's information that is manifested in the real world. We also have information that is instructional, the project information, intent information, where we determine what we wish to do in the real world. And then we have the semantic representations here in the project status information of what we monitored in the real world on the site. So we have status versus intent axis, we have physical versus virtual axis, but with the background that we all have in lean construction, we can recognize that we have a third axis. And that third axis is the axis of product versus process. If I show you the BIM model for a moment for a project here, a commercial building in Singapore, then it's quite easy for us to imagine that we also have a representation of the process. Now, both of these can be virtual or physical as they manifest. And that means that we can organize our information along three axes, which create 8 quadrants. So we have the building under construction, but we also have the construction process, both of which exist in the physical world. We have the project status information of the as-built, the physical representation of the building, of the product, but we also have the record of what was done, how long it took, who did it, where they moved, and so on, which is the virtual representation of the process as it was performed. And sitting here in the background, of course, we have the project intent information, which is what we would generally consider the design information in the BIM, but also the project plan, which is also project intent information, which exists in the virtual process world and represents our intent. We can also think of this information as growing across a life cycle. If we think of the start of conceptual design, designing, planning activities, and then we begin prefabrication, at some point we start construction on site, and we have the construction phase, handover, and operation, we can imagine the information accumulating in this way. As designed and as planned product and process information is compiled in the design activities. In the real world, we actually begin off-site fabrication and then the building under construction. We also have construction plant, and all of these represent information manifested physically. But as we build and we create new products and new realities, we can monitor those things and we compile as-built product and as-performed process information. Once we go into operation, we accumulate only the information about the building that we need for running and maintaining that asset, but actually we monitor it, and so we continue to accumulate as maintained and as renovated product information and the monitoring data. If you like, we can take the human twin metaphor a little further, and we can talk about, here over at this stage, conception, birth, weaning, and maturity, so that we can actually talk about a fetal digital twin, a child digital twin, a child physical twin, and then the adult physical twin and the adult digital twin. In terms of this metaphor, what I'm interested in for the purpose of our lecture today is the fetal digital twin, the child digital twin, and the child physical twin. Okay, so before we go on to describe what we mean by digital twin construction, we still need to define two more dimensions, that of data, information, and knowledge, and also the lean process dimensions. Information is compiled by interpreting data. The data itself, of course, has no value until it's interpreted, merged, and compiled as information that we can use. And then we need to compare information and process it to learn something about the status of the construction site that we're seeing. And that creates knowledge. And knowledge supports actionable decision making. If we think about the data in slightly more detail, then we realize that data are simply the result of the monitoring. They're a result of that record keeping that we see, and that indeed it has little value. So we need to interpret, process, compare it with other information, whether in the BIM model in this case, or with historical digital twins. And that's the first instance where we need support of artificial intelligence. Once we have information, which Floridi defined as data with meaning, then we're able to begin using that information to reach or interpret and reach conclusions about what we're seeing. And the goal of that, in terms of knowledge, we're concerned with the things that we understand about the processes that have happened and the products that have been created. So we're comparing what has happened with our theories of what should have happened, our intent of what should have happened, but we're also able to go ahead then and predict and extrapolate into the future using various optimization, analysis, and other techniques. And here again, we would use sophisticated models and perhaps AI to try to make predictions about the consequences of our future decisions. Now I'm going to move over to the other side here so that you can see the slide better. You can see then that the construction digital twin requires software modules to perform value judgments using information and thus to derive new knowledge. And the modules not only compare as built and as performed with as planned and as designed, they also make those predictions into the future. So consider, for example, information about a wall. We might conclude from the as built and the as performed either that it was not built in the right location, or that it was not designed correctly, or that it was built using the wrong materials, or that it took too much time, or any other logical conclusion that reflects not only on the reality that there is or that we intended, but also on our theoretical understanding of how that situation might be remedied going into the future. I am still here, although you don't see me. I simply want you to see the slide clearly. So the final dimension before we look at the digital twin construction setup is the dimension of the process itself. And here we draw from lean construction, and specifically from lean thinking and Deming, to consider the plan, do, check, act cycle. The real-time information streams from the site allow us this opportunity for the first time really to have a closed loop, short cycle time of checking and acting to improve situation. And since planning control is implemented repetitively as a construction process proceeds, we can really think of this as managing production as continuous improvement of the process that's taking place on site. And that incorporates everything that we do within master planning, long cycle time, phase planning, look-ahead planning, and shorter cycle times. But indeed, the weekly work planning on very short cycle times, and finally, day-to-day or hour-to-hour control and improvement, as we would like to see in many aspects. So if we consider the plan, do, check, act cycle in this way, then we can consider that modeling of the built facility is the first step, that planning action. The second one is the building itself, fabrication off-site and construction on-site. And then we have this monitoring and interpreting action, where we check what's going on. So we have digital monitoring of the facility, intelligent interpretation of the data to generate information describing the product and the process status. And finally, we have the evaluate and improve step, where we evaluate product design and process plan alternatives compared to historical and intended situations, And then we can improve the design by changing something in the BIM model going forward, or changing the construction plan. And then those things will actually play out in the construction site as things go ahead. And those are our actionable decisions, and they're applied through the digital twin paradigm. And so to summarize so far what we've defined in terms of the different dimensions for digital twin construction, we see that we have information dimensions and process dimensions. In the information, we have virtual versus physical, we have intent versus status, we have product versus process, and we have data, information, and knowledge. And all of those frame the way that we, in the end, define the process and the implementation of digital twin construction. In the process dimensions, we have the information lifecycle going from the fetal digital twin through the child digital twin and its physical counterpart, and ending up after the construction with the adult digital twin. We also have, during construction, the heart of the construction production control, the plan, do, check, act cycle, which in the context of construction, we interpret as, or we implement as, model, build, monitor and interpret, evaluate and improve. And that finally leads us to our model of digital twin construction. As you see in the big picture, we have here on the left the digital twin aspects, and on the right the physical twin. We have the design, product and the plan process actions. They feed and create the project intent information. That then builds and guides construction. We result with the physical twin, which proceeds day by day. We monitor it over here. And then we get raw monitored data. That allows us to create the project status information by interpreting it using complex event processing over here. We can then evaluate conformance over here by comparing the project status information with the project intent information, and that results in product and process status knowledge, PSK as we've highlighted it. We can then use that to predict performance going ahead, of course, using information from historical digital twins that have been archived, using generic design knowledge, product and process standards, and by predicting performance, we can then say what we expect to happen. That guides us to improve our design, product, and plan process information, generating a second cycle of project intent information, once again feeding build, control, construction, and so forth, closing our PDCA loops. So if we consider Deming's plan, do, check, act cycle, and consider how that plays out through the digital twin construction cycle, here is what we get in a number of concentric cycles. So here, using a color coding to show you how this works, that we have a section of plan here, plan, product, and plan, design, product, and plan process, and then build and control construction is our doing. We have our checking, which begins with monitoring, but actually is mostly concerned with interpreting and complex event processing and evaluating conformance. And finally, we have our action where we predict performance and then repeat design, product, and plan process in order to continue the cycle going ahead. So just to elaborate a little on this steps of interpreting and merging, we have down below here the various monitoring technologies that we spoke about before. And we acquire the monitoring data from those technologies. That information has to be registered and compressed before we can use it. But then this interpret and merge section over here that we highlight really uses complex event processing. And what we're trying to obtain from that is object geometry, surface textures, the paths that workers, labor, people took while doing their work, the flow paths of materials and quantities of materials, the paths of equipment, the information flows, and any events that might have been reported by people. So these different bits of information really reflect both product and process. And that allows us then to compile that project status model that we need before we can go on to generating knowledge. If I look at the kernel of the digital twin process and we compare it with the data information knowledge model, then we see clearly that we're progressing from raw monitored data through to project status information, and from there to project status knowledge and to project intent knowledge, which represents our future-looking prediction of what might happen depending on the decisions we make. And that, of course, feeds on and feeds into the project intent information. And if we look at the ways these play out in terms of lean construction planning and control, the final dimension that we suggested in terms of the process, we see here that we have these activities. Firstly, evaluating conformance, which means comparing the PSK to the PIK. And in that, we're not only going to compare the physical aspects, but we're going to measure and report waste. We're going to measure and report a construction flow index to understand how the quality of our flow. We're going to undertake an evaluation of the conditions of constraints for tasks so that we can compute a task readiness index for any future activities, and those may be within the next hour, day, or week. And if necessary, we can also solicit missing data. And these may partly be performed by people, but in the future you can imagine that increasingly these will be performed by software. We can also predict performance. So we can propose optimal look-ahead plans, we can use various kinds of optimizations to do that, and we can try to predict flow that might occur depending on the decisions we make about the next steps, our go or no-go steps concerning our activities. And so compiling a backlog of activities and knowing their readiness status is critical here to be able to predict flow. And finally, we can proactively initiate make-ready actions. That is to say, if we have made predictions and made decisions about work ongoing, not just in the next cycle, but the following cycle, a software could initiate purchase, it could initiate deliveries of materials and some other things, even providing pull signals. We could prepare the workable backlog, and indeed we could propose weekly work plans to last planner meetings that were already diagnosed or suggested in terms of optimal flow. And so we have numerous opportunities for application of AI going ahead, whereas in early stages we can apply the entire digital twin process manually. We do think that many of these actions will be able to be automated, and indeed will have to be automated on the basis of the very rich and broad quantities of data information and information that will be available. So what are we really talking about? I hope I've given you the impression that we're actually talking about a potential future new mode of construction. The title of the talk was Digital Twins for Construction, but I think it might be more accurate to call this digital twin construction. And while that doesn't necessarily replace any other labels like lean construction or BIM or anything else, it represents a new way of thinking about how we leverage all of the different components of our thinking to date to think about a slightly more automated, more productive, more cohesive construction system that is able indeed not only to control individual sites much better, but entire portfolios of projects. So the next step, of course, is to consider the business case. And this is very interesting because we see some of these aspects already developing and already in place through construction tech. So we can ask these questions about the data first. How will monitoring be provided? Well, presumably through service companies. General contractors are very good at outsourcing, and construction tech companies, particularly startups, are very good at innovating with sophisticated technologies. And in previous work, we've looked at how those two work together. So it seems fairly feasible that new construction tech savvy startup firms will provide a lot of that monitoring, and indeed many of them already are. In terms of the information, how will the necessary data analysis and complex event processing be provided? Well, here again, we see already specialist production management information service companies that are trying at this stage on the base of single sources of monitoring. But in the future, we can imagine that they will begin integrating different sources of monitoring so that they can provide far more comprehensive complex event processing and, in fact, provide the information that we need. And they will apply the AI, various forms of AI, for data analysis and pattern recognition. We see this in previous work on construction tech, AI, and BIM, recently published in Developments in the Built Environment. And I will refer to there to see why I claim with some confidence that construction tech, as a construction application of high tech, will have a lot to play, or a big role to play in all of this. And then in terms of knowledge, we really have, I believe, a digital twin construction business case to be made. So we can ask the question, who will run the predictive analytics, simulations, etc., and make recommendations about how to proceed with construction? Well, here, and it seems that over time, if there are outsourced specialist information service providers who are sitting on top or collaborating with construction tech companies providing the monitoring data, then these companies, the production management information services, will host the information and the knowledge about projects as an outsourced service. And here, of course, they'll be using AI for data mining, for parametric design, for process optimization. And because they're providing a service online, they're not necessarily constrained to be present on the construction site. Which leads us to the supposition that we may see in the future digital twin construction control rooms, which would be the site office, perhaps, to an extent, perhaps not all of its functions, but many of its current functions might be moved to office spaces which were permanent and could begin to monitor, control, encourage production control, and indeed cross-project portfolio control of construction from day to day. And that would, of course, have multiple business benefits because they would also be controlling a lot of the purchasing, deliveries, coordination, fabrication, and such like, which once that were done either off-site more or on a portfolio basis rather than an individual project basis, has obvious business benefits. And so to try to wrap this up, let me just sum up some of the highlights we've seen. Digital twins comprise intent and status. They comprise both product and process. They function as systems within systems. And the digital twin construction as a new paradigm is an information process as much as it is a material process. And there are research challenges, of course, associated with this. There are information research challenges, whether it be complex event processing to derive information from monitored data, information representation challenges, where we may need property graphs and semantic web constructs instead of our standard BIM files that we've become used to today. There will be process challenges, integrating AI for interpreting status, as we said. There'll be challenges in terms of control and management of production, how we get shortened cycle times for PDCA control and to what fine degrees of time we can take that. And if you're interested in those areas and you are soon to finish a PhD, there is a new European research project funded by the EU under Horizon 2020 called BIM to Twin, which is now hiring postdocs, and you're welcome to write to me if that strikes your fancy. I began the talk by raising the thinking innovations that we have on the table today. BIM, lean construction, monitoring technologies, artificial intelligence, and digital twins. And I hope that I've managed to argue coherently that these might all come together in something that in the future we may term digital twin construction. Before concluding, I do want to acknowledge colleagues who have contributed significantly to the digital twin construction thinking. At the University of Cambridge, Professor Mark Girolami and Yannis Proulakis, Hayam Shia and Mark Enzer. At Aalto, Ergo and Ollie, whom we all know well. At TUM in Munich, my colleague Professor André Bormann, all the members of the BIM to Twin Consortium, and of course our colleague Bargev Dave of Visinine. Thank you all very much for the support and engagement. I will leave you with a very short bibliography of the key texts that underlie much of what I've talked about today, and I hope that you will find those of use in reading further and understanding the topic better. And with that, I will ask for your questions. Thank you very much for your patience.